Physics time! Alright, here we go. We're going with parallel circuits, slides. Cue the music.
This song's gonna get stuck inside yo. This song's gonna get stuck inside yo. This song's gonna get stuck inside yo. Hey!
We're back. Is that cool? Whatever. Alright, parallel circuit, slide 7. Here we go. I tried to draw it. 6 volts, and we got 3 different loops. One thing to note, I wrote 1,000. On yours it says 1 K ohm. What does K mean? Fancy edit maybe? I don't know. Means kilo, which is 1,000. That's a trick. Remember back in the days when we could actually hang out in school? It was a trick I used to love to throw at you guys, and you loved it, I think. Anyway, that's the only difference here. Whenever you get a diagram, you always ask yourself, is this a series or is this parallel circuit? So, what does it look like to you? Exactly, it's parallel because we can see the different loops. So, let's get a yellow. Yellow? I don't want yellow. Why did you load up yellow? Red? There we go. Red, let's call this one the red loop. It comes around, that's one path the electrons could take. We got brown. The brown loop could be this way. Coming around, and the last one, camera. Yes, thank you. Blue. All right. The blue loop. So we got 3 different loops here. Yep. Orange. Save that for later. We have 3 different loops, and because we have 3 different loops, we know that means it has to be a parallel circuit. So we can check our reference table. If you lost your reference table, I'm sorry, but you can still Google it. Just Google physics reference table. If it still exists, hit the I'm feeling lucky button. It's the first one, even if you're in Florida. So here we go. V, 6 volts, equals V1 equals V2 equals V3. And that's a nice little property here. The benefit of using a parallel circuit is each loop is like it's connected to its own 6-volt battery. So if you were going to cook several hot dogs with an electrical cord, you want to hook them up in parallel so all your hot dogs will cook just as fast if it was just one alone. They would be getting the full voltage from the cord. That's good. The current is flipped with the series 1, and it's I plus I plus I. And that's because you have the red path, the brown path, and the blue path. And all 3 of those are going to add together. You got all those electrons leaving, splitting up, and coming back together. And now the last one, which isn't that far into the notes, it's not on slide 7, but we're going to get into it anyway since I'm making a video. It's all about figuring out what the equivalent resistance is for a parallel circuit. Anyway, we'll get to that down here. First, what is the voltage at each resistor? That's a great question because we need this equation for the voltage because that has each voltage in it. So we got V equals V1 equals V2, equals V3. So I know the total voltage, they give it to me, 6 volts. So now I know V1, that's 6 volts, and I know V2, that's 6 volts, and I know V3, that is 6 volts. That'd be a great question to have on a Regents exam if only that still existed this year. Easy points right there, it's 6 volts all the way across. The next one, a little tricky, what's the current at each one? So let's see. Here's the first resistor. I know the resistance. I don't know the current. I do know the voltage is 6 volts. Okay. Same deal here. I know your voltage is 6 volts. This has got 3,000 ohms and a mystery current. And here your voltage is again 6 volts. Mystery current 2,000 ohms. So in circuits, your most important equation, Ohm's law, V equals IR. And where you got R, we got I, we got V. So we're going to just do that 1, 2, 3 times. Because we want it at each specific resistor. So we want to use the specific numbers for each resistor here. So I'll write that out. V equals IR. I don't know why I'm writing I. Mental slip. V1 is what I wanted, equals I1 times R1. So V1, you look, we got 6 volts. That's the same way we're solving for I1. And now the difference in each of these will be the resistance, 1,000 ohms. So I do my division, 6 divided by 1,000, I1 equals 0.006 amps. Is that right? Check it. Yes. We're going to just repeat this process. Plugging in these numbers, the 6 and 3000 and the 6 and 2000, do your division, you should get other numbers. Maybe we'll play a little theme music on the snap. You think I'll be able to edit that successfully? Volts, I agree. 2000 ohms. Revision. Alright, so we got all three, and they wanted the current through each resistor, and we have all three. So we get 0.006 in this loop, we get 0.002 amps in this loop, and then in the last loop we get 0.003, which naturally leads us to the next question: what is the total current? The total current is this equation here. So I equals I1 plus I2 plus I3. Got all those. So I is equal to 0.006 amps plus 0.002 amps plus 0.003 amps, and that gives a grand total of 0.011 amps. That's nice, makes sense, it's bigger than each one, and that's because each loop is its own path from the battery carrying its own electrons. This last one, total resistance, is the crazy one. And for this one, if you haven't already, go back and look at my bucket video demo. And that kind of explains how the resistance in a parallel circuit will decrease even though you're adding in more loops with resistors on them, which is a little confusing, but I think that bucket video should help clarify it. Oh, okay. Oof. All right. So we want to use this equation. I've fallen because it's hard to write at the bottom of the board. So the total resistance, we're going to use this. It's not like series. It's a little more difficult. You can't just add up the numbers. That won't work. And again, that's because when you add loops into a parallel circuit, or add loops into any circuit, you're going to decrease the resistance of the circuit because you're allowing more paths for the electrons to flow. It's like even though there's traffic in all three lanes on the highway, you're still moving more cars than if you had a 2-lane highway. You know what I mean? Remember when we used to have traffic because we could drive? Alright, so we write the equation 1 over Req equals 1 over R1 plus 1 over R2 plus 1 over R3. These are tricky because it has so many fractions and we hate them. 1 over Req. I don't know who your elementary school teacher was, but if you don't like these, you can't do them, their fault. 1 over R1, way up there, we get 1 over 1,000 ohms. Use your parentheses, especially when you're in your calculators, people. Even if you're using the Google scientific calculator, which works great if you don't have a graphing one or a scientific one, use your parentheses. Then we got 1 over 3,000 ohms plus 1 over, almost forgot the parentheses, 2,000 ohms. So now we get 1 over Req, and this is important to keep writing this out as a fraction, equals, we're going to get a decimal on our screen. The decimals should say, oh, there we go. Oh, no, that's not it. That's the wrong number. Oh, goodness, I need to bring the paper in. The decimal says 0. Such small handwriting. 0.0018, and then 3 repeated. The units here are 1 over ohms because it's 1 over ohms. So what we need to do is cross multiply or do the inverse of this because we don't want 1 over R, we want Req. So that's equal to 1 over 0.001. 183 ohms. And that will give you the real answer, which is 545 ohms. Now, one nice thing to check, whenever you do your equivalent resistance in a parallel circuit, it is always going to be less than the lowest resistor. Doesn't make sense because you're adding numbers, but you're adding fractions and stuff, and you're poking more holes in the bucket. It should always be less. Now, if you don't like this and you keep trying and it's not working, there's another way to do this. Yes, exactly. The alternative way is just to use Ohm's law. V equals IR, like we did with a series circuit before, I think. And you just use the total numbers. So I know my total voltage of the whole thing for the battery is 6 volts. I know my total current is 0.011 amps. So I can find my total resistance. And if I just do my division here, I don't know why I'm even double checking, I know it works. 545 ohms. So this is a nice way to check. I do both, to be honest. If I was doing an exam, I do both to make sure it comes out the same. That means I know I didn't make a mistake. You may want to do this way, just getting used to and always using Ohm's law. But the issue here is you have to do the current. So there could be a question that skips this middle stuff of the current and just gives you these three numbers and say what's the resistance. Then you may want to just go straight here and do it. If you don't mind doing the middle steps, you can do the middle steps and avoid these fractions the whole time. It's up to you. So that's that one. This is everything they could ask you. If you have more questions about this, email me. All right, signing off. First one.